I decided to use to load the data. So my first question here, so so what that I asked you about train data and test data. If you were supposed to merge them together, because later on we use that train and something split. So you said I use train data only.
So yeah, so ideally you should think of the test data as data your model has not seen. So you can just do your analysis using train, and when you do your model, you can test it using the test. But now that is way down. So the first thing is to start by analyzing the train.
Okay, and then so my other question is all those other files, the session, that age file. Does the train data already combine all that, or you're supposed to look at those other files and now put in any other information you want?
Yes. So it's up to you to look at which data you think can be merged. You merge. So it's really up to you to decide.
Okay. Okay. Then I had loaded one of those files, the one that had age, gender, and population stats. So I just looked at what was in it. And then I went to now the train data. I got now the information from train data. So I did the head, got the description. So like for the description here, for age, like one of the issues, if you look at this, you can see the mean age is 1, max age is 2014. So I'll come to that one because I have a question on that one. So let's just go down. So the information here shows you the null information. Where have I gone? Which one has missing data? Where have I gone? The info, yeah. From that you can see which one has missing data. So your date first booking, age, and first affiliate have missing data. And then it shows us how many null values are there. And then, so this is just doing an analysis of the data.
Of course, you have to deal with null values.
So for, I think there should be a question there.
Oh, then you don't need to use print. Angela.
Okay.
If you remove print, it will still work. You don't need print.
It will still work.
Yeah, because this is Jupyter Notebooks.
All right. What was I going to ask? Okay, so null values. Now that's where we put in something like unknown or not a number. I've seen something like NaN, not a number. That's what we do there for the null values.
Null values are the ones who have those NaN. So it's up to you to decide based on your analysis how do you want to deal with them. So that was up to you to decide. This is how I deal with null values in the age column. This is how I deal with null values here. So how did you do it?
So so like take for example the age.
Like for example, where you have age as 2014, you probably decide there is no one going to be that old. You decide maybe let me put the mean. Or where there is a null value on age, you decide let me put the mean or median. So it's now the first step of cleaning, removing null values, all those things, because you can't proceed if you have dirty data.
So you can either remove them out, those rows out, or you can decide to use mean. Okay, so that's part of the things I need to do.
You need to decide. If I remove them, do I end up deleting everything? Do I lose a huge percentage of the data? Because if you drop them and you lose maybe just 2 or 3, then you can just drop them. But if you drop them and lose half of it, then you see dropping is not the best thing to do.
You can now put in mean values there.
mean or median, depending on which you think is the best.
Is the best. Okay. So I need to do that because so I noticed that you have ages like from 1 to 2014, and that doesn't work. So I was not exactly too sure what to do.
Did you check other notebooks?
Yes, I did. There are some which I didn't exactly understand what they were doing. Okay. So we had done this in class for separating the year, month, date. So I did that for the date account created column.
Uliandika mwenyewe ama uli copy paste?
A mix of the two. Check, then it split it out here, month, day, year. Still getting the hang of it, so yeah. Okay, I tried to do a group by, I don't think it worked. Okay,
so what you're telling us from here is that the country with the highest destinations is this one, no destination found, followed by US.
Okay. Yeah. So then I did pair plot. So okay, so then before so like now the age, when I find the issues with age, I need to correct the issues before I start doing the
visualization. Yes. Because
so
you could even decide this column does not help me in any way, so you can also decide to drop the column.
Okay.
But that's up to you to decide.
Okay.
From your understanding of the problem.
Okay. Then I did a bit of visualization, which I will need to come back to once I clean the data more. So this one was a gender versus destinations. So it shows the destinations and the genders that went to those destinations. I did one on the percentages of bookings for the destination. And we saw this one, NDF was the most. I did another group by, it was by age, but that didn't come out too nicely. So I looked at the unique values and the sign-up method. It's a bit all over the place, but yes, I was trying to get the hang of it.
Then add your comments using Markdown.
Markdown, not the hash.
Those are just comments, but now if you are doing notes, you change. Unaona hapo kumeandikwa code, you change that to Markdown, and then you write what you want.
Okay. So then I did a line plot for the.
Can I ask a question?
Jamal, you have a question?
Yeah. While he's doing the visualization, especially the graph, does she needs to include the NDF? Because I'm like, if you're going, because NDF means no destination was found. That means person never booked.
Can you please repeat and then uongeze volume kidogo?
Saying, while she's doing the visualization, that she needs to include the NDF, the no destination found.
Yeah, it's under the countries. It means that no destination was found.
So did she book?
So we need to know how many of those records have that no destination found.
Okay. Yeah, so basically the rest of this part, so I need to come and redo them again once I clean the data more. So these are the devices that were used. This one is a language. So we see English is a mostly used language. Yeah, and that is about it.
That's
So
okay.
there's still some work I need to do.
That's okay. Let's see what we can learn from others. Jamal. Fiona, you have something to show us? After Jamal, we go to Fiona. Jamal.
Can we start with Fiona? Mine is still not really trying to look for the notebook sheet.
Fiona, is yours ready? Fiona, can you hear us?
I don't know if she's just logging on, like her camera is not even showing and she's on mute. It has got, yeah. So you can
I'm assuming as Fiona presents, everyone read through the problem so they understand what we are doing. We don't need to explain the problem we were solving again.
So I proceed?
Yes.
Okay, so first thing I did was import the necessary libraries, but you can go importing them as you move. Reading the data sets. I prefer to explore each data set on its own to try to get as much information as possible. Yeah?
There are some people who have probably not even looked at these data sets. What does each one of them have?
Oh, yeah, sorry. So age, nimezipanga in order hapa kwa cell 2. Age contains the summary statistics of the user's age. Countries contains the summary statistics of the destination countries. Session contains the web session log for users. Sample is just the correct format for submitting your predictions. And then train is our users that we're supposed to train our data with, and test is where we're supposed to lift our model from our training data. I hope that makes some sense. Then I went ahead to explore every data set. So there were 3 of them that required, actually 4 that required to be looked at. There was age, countries, sessions, and the train set. So in age, I just looked at the descriptive statistics using describe and .info. Just looking at the distribution, basically looking at each column, looking at what is interesting about each column, unique values within each column, and their frequency. That was just it. Then I did some visualization for the age data sets just to see how variables are related. So for this, this is age, population of the place where they're going, and the gender. So from this, my observations were the largest population that traveled was between 47 and 52. As you can see, it has the highest bars here. Another observation is the population count. Okay, yeah, these are the observations that I was able. This was just basically looking at it, getting a feel of the data. There's really nothing much important about it as such. So I did my analysis of the age data set. Then I moved to the countries data set. I did the same thing. I performed my univariate and bivariate analysis for each data set separately. So for example, I started my analysis for the countries here. You can now see here we're looking at relationships between the variables. Like here, for example, my count is country popularity. My country popularity is coming from here. This is where the parameter count is coming from. So country popularity is basically just how many times that a country appears when it's not no destination found and it's not other. So that's basically everything else, as you can see on cell 64. Then I created this data frame that contained all that data. I just concatenated it and brought things together. Then I drew a heat map to look at the correlation, so that it's a bit easier to already tell the relationship and the direction of the relationship between variables. So as you're visualizing, you're more of just establishing what is already on your heat map of correlation. So that's what I was doing. US was occupying a very big part of the data set. So I was trying to see some visualizations with and without US. For example, this is the correlation between how many times a country appears and the distance from the country. And then this is on cell 74 is when you drop US, because US was a very big percentage of the data. And when you drop US, actually you can see that some things change. So I guess it's about exploring your data in every aspect that you can think about it. So for this is just looking at parameters, relationship between parameters. This was my bivariate analysis. Then I moved to sessions. Sessions did not really have much. It's going to be dealt with a bit later. So I just looked at each column individually, every unique instance within that column, how many times it appears, that's using the value counts. I did some visualization, some univariate analysis so that you can be able to get some insight into it. For example, we can see that the largest action type is view. I went into the seconds. I tried to look at the distribution of the seconds that were elapsed. It looked like a couple of them were less than 5,000 seconds long. So I decided to look into those sessions that are less than 5,000 seconds long, and within them, most of them were less than 1,000 seconds long. So there was really nothing much about that. Then I looked at the device type. I realized that most Apple products are especially popular because Mac, which has the highest number of users. iPhone has a very particularly high number of users, as well as iPad, and they're all Apple products. So you can conclude that Apple products are very popular within Airbnb users. Then I finally got to the train set. I looked at information, descriptive statistics. Then I started my univariate analysis. Again, I just looked at the distribution of each column before even looking at if it's related to anything else. So I did a visualization for each and every column to try and find what I could find out about every column. So that's what was happening in there. That's just visualizations for each specific column. Then I went to, wow, there were like a lot of columns here. Then I went to my bivariate or multivariate analysis. I did the same thing, but mostly what I try to focus on is looking at the relationship between an independent variable and our target variable. So age and gender is not all that. So I started with age and destination, gender and destination. I kept checking each and every one of them like that. Sign up method and destination, each column and destination, basically to see if a column, or rather a variable, if it has any relation with the destination, which is our target variable. That is what I did for a couple of them. Then after that, I started feature engineering. Feature engineering is where you now start preparing your data for your model. Before as I was doing the visualizations before, I didn't drop any values, I didn't do anything. I just wanted to look at the distribution of the data exactly as it was to see what I could get from it. So now feature engineering is where you can start dropping null values, doing transforming some few things here and there, such that you're trying to get more information from your data that is going to help your model perform better. So,
Fiona.
Yes?
Actually, you should have started with cleaning at the top. like just like cleaning. I'm saying like even before doing visualization, the first step should have been cleaning and removing any null values and whatnot.
As I was doing the visualizations, I tried to I used drop any as I was doing the visualizations. I didn't want to drop the values at first. I just wanted to see the distribution because maybe the null values could be telling something. So
Yeah,
I
that's why
didn't.
you should have dealt with them, like either feeling them, not
Oh,
just to drop them. Yeah.
oh,
Because you
okay.
might drop some things which are actually useful in your visualization.
Yeah, okay. Sour, noted. So for feature engineering, I tried to get some information from the sessions data frame because there was not much about it that we did. And from the problem statement, we were told that the sessions data set was to be joined with the train data set on user ID. So I tried to concat what I got, what was important from sessions with our train data. Basically now here, what in these following functions, what I was trying to do was now dealing with categorical variables. I was trying to reduce the number of categorical variables within each column, such that because I'm going to apply one-hot encoding, I wouldn't want to have many columns because if that happens, we're going to overfit our model. So basically, that's what these very many functions are doing. So after I did that, okay, within these functions is where I did most of the data cleaning. If there was any edges that were, for example, age, there was an age that was 2000. So something about ages, I dealt with them during feature engineering. Apparently, I should have dealt with them at the beginning, noted. Sorry, I
Can you
didn't.
just show us, sorry Fiona, can you just show us there how you did that, the age part, and if you can explain that lambda. I saw that a couple of times, wasn't clear. Yeah.
Yeah.
And Fiona, if you could have done dot describe, you could have seen the age at the very beginning. You do not even need to do any visualization. Like the way Angela and Dan dot describe, you immediately you see there is an age that is 2014. So obviously,
Okay.
you see there is an
Yeah,
age that is 2014. You can't continue visualizing at 2014 age.
okay. Let me look for age. Where did I use age? Ooh.
Like if you could have just done, your work is very good. Just if you could have just done describe in the beginning, age dot describe. You could have
Okay.
seen. You could
Here
have
it
seen
is. Yeah, I can see. Sorry, age dot describe. Yeah,
no.
this. Okay, so what I did. For the age data set, what I did was this. Let me convert this back to code. For the age data set, I just created mean age so that I could take care of the age buckets. That's not where I dealt with age. I dealt with age a bit later in the data set. I think when I was
okay. You can deal. No, it's okay. You can deal with the lambda now.
Yeah, I'm looking for where I put it so that I can explain it from there. I honestly don't remember. Okay, let me show you something else that I had done a bit before. No, where is it? Final submission. Okay. Wow. Okay. Can I just use any other lambda function because I really cannot see where I put it. Okay.
Just go to that feature engineering thing that has so many lambdas.
Okay. So, for example, lambda. Let's deal with this.
Go to where the feature engineering is. That function for feature engineering.
Okay.
Kuna lambda mingi sana.
Yeah, that's what that was. Where is it? Feature engineering.
Jamal, hope you're getting yours ready.
Okay. So what this function does, you're telling it lambda x is the argument that you're passing. So that could be anything that is what you're trying to check for. So X is the parameter you're passing. The first thing that comes after X is your return value. So what I expect to be returned from the function that I've highlighted is total seconds, X. And this return value is being returned if the condition, if X in total seconds is true. Otherwise, the return value is going to be 0.
Angela, do you remember the function you did for coming up with the age, the month, all that?
Sorry, just repeat that.
The function you had in your notebook for doing the age, the month.
Yeah, yes.
So now using a lambda function is just a shortcut instead of writing all that.
I think this might be a better example. So this is what I did for age. Lambda X 36. Okay, so what I was passing here is my age parameter, which is train age. So what I was telling it is train age is now my X. The value of train age is my X. So what I'm telling it is, so lambda X means X is what I'm trying to check. And then I'm telling it return 36 if X is greater than 100. So everywhere that X is greater than 100, it's going to be replaced with 36. Else, leave the value that is already there. This is what a lambda function does.
Yeah, and Fiona, that what you've done there in the lambda function, you could have created a function to do that.
Okay.
Sindio? Like you could have created a function that can just do this thing for you. True or false?
Yeah, true.
Yeah, so this is just a shortcut.
Yeah, it's
so
a shortcut.
some people don't like lambda functions. Like I don't prefer them, but they are very quick. It's like least comprehension. They are quick way of doing these things. So if you don't like using lambda functions, you can just write a normal function. It doesn't mean you have to use lambda functions.
Yes, by the way.
Yeah.
So there was a lot of visualization happening. So after I ran all these functions on my data frame, my final data frame looked something like this. So my, oh no, not this. Where is it? Okay, I'll show you in a bit. So after I got my, okay, so during feature engineering, I tried to reduce the number of categorical variables within each column, because if there are going to be so many and we're going to apply one-hot encoding or global encoding, whichever, if that means it's going to create more columns from those variables, and the more columns that we have, we're going to destroy our model. So I tried to launch them. Yeah.
Some of us are wondering what is one-hot encoding, what is global encoding, and what's the difference?
So we have, when we are trying to pass our data to our model, if we have several categorical variables in a column, for example, something like gender, we have maybe male, female, unknown, other. However, the model is not going to be able to understand what we mean by male, female. So we have to give it, we have to give that information to the model in a way that it understands it. And the model understands numbers, that's binary zeros and ones, basically. So what label, you can decide to use label encoding or one-hot encoding. One-hot encoding, however, is better because with label encoding, you start passing, you give labels to the various categories, and the machine learning is about history. So if it starts seeing, like for example, you can see on cell 73, 0, 1, 2, 3, 4 till 11. Because machine learning is about learning history, it could start looking at it as if you're trying to create some certain order. So it can start coming up with 12, 13, 14, 15, 16, which is not what we want. So I usually prefer using one-hot encoding, but for the output, I just used label encoding. For one-hot encoding, this is where we use pd.getDummies. And let me show you what it does. So you can see that from So for example, you can see our first device type, we have desktop, phone, etc. And when you come to our train set, after we have created our dummies and we've applied one-hot encoding, you can see there's a column for desktop, there's a column for phone. Probably tablet is another thing that we can't see from the data frame of now, and also is unknown. That's why in my feature engineering, I really tried to crunch the number of
Fiona,
yeah.
for pd.get dummies, why didn't you use drop fast is equals true?
Sorry, I forgot.
No, I'm just asking, maybe the executions
sorry.
where
No. It is I was supposed to, then I forgot. Sorry. Drop first. Yes, I was supposed to actually do that. Thank you for reminding me. It's likely to improve the accuracy of my model. Thank you. So
sorry, question.
Applied. Yes.
So that's just that one line. That's
pd.get dummies.
to pd.get dummies will automatically change all of those things to coded values. So
Yes.
you won't have to do what you've done for the label encoding.
No. That's why I prefer one-hot encoding. It's a bit easier.
And x in this position, in this situation, what is x exactly?
X.
X.
No. X is my independent variable.
Features.
I think I should have started here. So I have my data. This is my data frame. So I'm trying to, what can I say? I'm trying to get what is important for my model, because as a whole data frame, not everything that is in this data frame is important to me. So I'm just trying to get what is important to me. And something like device type, it looks like it is important. So, but it has a lot of categorical variables within it, and that's why we're getting that we're doing pd.get dummies. So my x is just my independent variable that I'm going to determine variable. So after that,
Did you mention something like global encoding or label encoding?
Label.
Okay.
Yeah, this one. So after you encode, you can now pass your parameters to your model. Oh, sorry. I split my, so I've shown on the cells above here. Sorry about that. I split my data, obviously. And then after you split your data,
stratify. We are wondering what stratify is.
Stratify is okay. It's a very optional parameter. It's mostly to just it's about some cross validation, such that you're going to be able to sample a bit more of everything in your data set, so that it's a bit more random and a bit more accurate. It's nothing too important. Then
why did you say is equals to y?
Let me see.
And what is cross validation?
Stratify. Wow, why is this here? Let me try remember why I used stratify. I honestly
just proceed. You when you remember, you'll tell us.
Yeah. So after you split your data, you now move to model selection. After you've already cleaned your data, you've done your feature engineering and split your data, you can use any model. So it's just up to you to define what model you want to use, and then you're going to figure it out. So the first model I decided to use was random forest. So you import the classifier, you instantiate the classifier, and then you fit your data. So you fit X train and Y train, and then you predict. Using predict, so that you're able to see how your model is performing. Then you import your metrics, And so I looked at the classification report. Remember, you pass the true parameters and then the predicted parameter. So from here, the accuracy of this model was 60%.
Why using a FI score as the score and not the weighted average accuracy?
This one, the accuracy. But I also, I also did it. You can see the accuracy is 60%. The other parameters, I was not particularly interested with them. I really don't. Again, precision, recall, and F1 score, they're subject to what you're trying to do with your data. Personally, I was not so interested in it, so I just looked at accuracy. I was trying to do some few things that didn't work. Then the other thing I tried to do was logistic. The other model I tried was logistic regression. Import it, instantiate it, fit your data, predict your data so that you're able to see how your model performs. From here, we can see that our accuracy dropped to 58. So random forest so far is a better model as opposed to logistic regression. Next, I tried to use decision tree. I don't know what happened, to be very honest. I tried to predict, it was giving me some error, so I couldn't figure out how the model performed. I also tried XGBoost. I've been trying to, from what I saw, XGBoost is what gave the best accuracy. I've been trying to import it on my laptop in my kata, so I don't know how accurate that's going to be.
Are you sure it's imported from a scalan?
Nimeona hivi ndio inaimportiwa from scalan.
Naona hapo imesema no module named XGBoost.
I don't know, this is how nimeona inaimportiwa on other notebooks, and I don't know why it's not working for me. So I don't know.
I'm not sure. Find out. I'm not sure that that's the way it's imported.
Okay, I'll find out, because this is the classifier that seems to give the highest accuracy. I would have really wanted to look into it, but I'll try to find out.
So the other way you could have done, instead of doing the classifiers one by one, is you import all the classifiers and then you run it in a for loop. Then you check the best accuracy instead of doing one by one.
Yeah, I should have done. I hadn't thought of it. Okay, yeah.
Then you also can do what is called grid search, where you pass in different parameters and see which parameter. You check which parameter gives you the best results.
Yeah, I wanted. Okay, I will definitely look into that. So after we have learned how our the two models that I was able to find how they are performing is the random forest with an accuracy of 60 and logistic regression with an accuracy of 58. So after I already know that, I can now lift that model to our test data. So this test.head is the test data that we were given. It's the test users. So what I have done here is the function feature engineering. Where is it? This function.
Yeah, we can see it.
I want to put it closer to where it is being used. Yeah. So after we've already discovered the accuracy of our model and such, we can now lift our model and introduce it to data that it hasn't seen before, so that it's able to predict for us. When it tells us our accuracy is 60%, it means that what it's going to predict for you is going to be 60% accurate. So this method, this function, everything that has happened in here is everything that I also did for the train data, so that my train data and my test data zitakuwa zinafanana as I give it to the model. Otherwise, if it has different parameters, the model is going to give me an error. So that is what I have done here. I passed the test data frame through the feature engineering function, and so this is now my test data frame that is going to be passed to the model. As you can see, it's very similar to our DF chain. Sorry, I've changed a few things as it was running. But anyway, so now our parameters for our test data are the same as the parameters in our train data that we passed to our model. So what we do, so what I have, this is now what is going to happen. Because the data was already fit during our training, for our test data, we're just going to perform a predict. It's not going to be fit or anything. So model was my linear model, was my logistic regression model. So this is the predicted values from the logistic regression, and then this is my predicted values from my random forest classifier. I've actually just right now, I've realized that my predictions were made in 0, 1, 2, 3, 4. That is following the label encoding that we did for the countries. So that means that if you see a 0, that means that if you see a 0, it represents no destination found. If you see a 1, it represents US. If you see a 2, it represents other. You see a 3, it represents France. I know I should have changed that before I appended it to the data frame. That's what I'm trying to do at the moment. But currently, my predictions look like this. Okay.
Did you manage to put them in the format of the submitted CSV file?
That's what I've just realized. I didn't convert the 0, 1, 2, 3 back to the countries. That's what I want to do, and then I put it in the CSV. That's what nimebakisha.
Okay, questions?
I think I'm even more confused now. Oh my God. That's a lot.
It's a lot.
It's 2 weeks. It's 2 weeks of work. Of course, it's a lot.
I went through the notebooks that were on Kaggle, so I've combined a couple of things from very many places. That's why it might look a lot, but I wanted to be able to cover all ground, and I think I was able to. But yeah, it was a lot. It really was a lot.
It looks good, as in there's a lot on my end trying to take in all that. There are some things I'm like, did we do that?
Yes, I'm very sure everything that was here we have done. We've encountered it in class.
Maybe apart from Lambda.
Okay, maybe apart from Lambda. But I think it was, maybe we encountered it when we were doing Python introduction, but that was quite early. People might have not understood. But basically what I figured out when I was looking at the notebooks, what I figured out is the best way to go about it is look at the reading your data, cleaning your data, as Derek has said. Then you perform your analysis. Try to look at each column within a data set by itself so that you can see what much information you can get from it. As I was doing the visualizations, etc., I was trying to put some notes at the bottom. So, for example, with our fast browser, you can see that our most prominent fast browser is Chrome. So, with this, maybe they know that they should focus their efforts maybe on their website that loads on Chrome, so that it's better and they're able to get more users. Basically, you're just trying to get some insights. Just look at the distribution of each and every column within the data set. And then now you start looking at relationships between the variables. So you're looking at this and that. I mostly looked at every variable with our target variable, which was our destination. That's where you can see gender and destination, sign up method and destination. So I just did everything to see if anything is impacting our target variable. And then after I did all that, I now got to feature engineering. feature engineering is very important because not everything that is in your data frame is important. For example, in my feature engineering, I ended up dropping some columns. For example, something like date account created is not important to our model. The date of first booking is not important to our model. So feature engineering is about preparing your data to go into the model. It's a very important step if you want to get an accurate model. After you do your feature engineering, you now move to model selection, splitting and chaining your data. Again, because this was it was a project and it's mostly about business, you would want to look at the accuracy of different models, so don't feel like you should just use one model. Probably, I know most people will have thought of using logistic regression because it's what we learned in class, but logistic regression it's a very basic thing, so it may not give you the accuracy you want. So that's why I have used different classifiers, and you then you check their accuracy. As Derek has said, it will have been easier to import them all at once and go through them in a for loop, so that we'll be creating a function. But it will definitely be easier because you're going to be able to see everything at once. After you've checked the accuracy of your models, once you're satisfied with that, you can now lift that model to your test data. And remember, what you did, the preparation that you did on your training data before you fit the model is the preparation you have to perform on your test data. Otherwise, the model is going to give you an error because it's going to tell you that the parameters are not similar. So this whole feature engineering is what I did for my test, for my train data. So what I'm doing here is exactly the same thing, but for my test data. And then after that, you lift your model. So after that, after you've made your parameters to be similar to the train data that you use, you can now lift the models that you used to fit your data in your train data. That's what is happening here. And because you already fit the data, you just want predictions from this model. You're not going to use .fit, you're just going to use .predict. I'm sorry about this last bit. I'm going to try convert the zeros and ones back to the country. But basically what this prediction is telling you is if the prediction is 0, it means it's no destination found. If it's 1, it's according to what is on that list. So I'll try convert it back and then it should be a bit more clearer. But basically that's it.
So probably what you can do is finish up, clean it up, add some more notes, and then probably upload it to Kaggle and see how many upvotes you get.
Sawa.
Tanvir, Jamal, Millicent, questions?
No questions.
Comments, compliments?
I think I'll compliment Fiona. On a light note, she has said everything that I wanted to say.
Thank you.
But I think it's a challenge to us. Me and Tarvir, next time we shall present ours to you personally.
Now show us what you got. You said you did something.
I can't seem to find my updated notebook file.
That's a lie.
Okay, I worked on it around a week ago, so since we are still, for us who are in essential services, we're still working, so this time I submit.
But you were working even when we were doing class.
Okay, I guess physical classes and virtual ones, we are still trying to adjust. With virtual ones, once you exit the screen.
The same thing to class. Once you exit the class, you never open a notebook again. Millicent left. So if anyone has questions, they can ask because that will be all for today.
For today or forever? I thought this is our last class.
Oh, we are done. So if you haven't done the work, it's up to you to do it. Yeah, ask questions.
Yeah.
Those who have not done,
again,
if you do, you can send
again,
it to me. I look at it.
I went through the notebooks on Kaggle and tried to get as much as I could from it. So everything on that notebook is from those notebooks on Kaggle. If you can go through them, some are definitely simpler than others, but some of them are structured. I think I will send to you the ones that I feel are a bit structured so that you can be able to follow through on your own.
Yeah, that will help. Thanks.
So.
Well, I hope you guys have learned something over the past few weeks.
So when does the advanced classes start?
Liars with Alice. I think there's one ongoing.
Cool.
I talked to Alice. There is currently one ongoing, but it's at week 5, so it will be a bit tricky to join now. She told me the next one should be starting about a month from now.
Maybe a question, Derek.
Mm-hmm.
I went through some Kaggle. I saw some guys were using things to do with neighbors and Gaussian something.
Sorry, I can't hear you.
Hello, I'm saying when I was going through some notebooks in Kaggle, I saw some people had used things to do with neighbors, and then Gaussian something.
Okay, nearest neighbors.
Alongside, yeah, alongside the random forest. So
There's so many algorithms, so you just need to go and read on them and how they work. Like we've not even touched the surface. There are so many.
Okay. So they're a bit advanced on them.
That's why we're saying once you've cleaned your data, you've prepared your data, you can now use any model that you think is relevant to you. That's why some people might have used KNN, others have used random forest. It depends on what data you have, which model you want, how much accuracy you want. So for the one who used KNN, that's a classification. Maybe it was a classification problem.
Clustering.
Sorry. No, clustering is k-means. Clustering is k-means.
Oh, it's k-means.
Yeah, KNN in your classification.
Maybe I'm confusing the two.
Yeah, it gets a bit confusing, but I'm sure k-means is your clustering. So depending on what you want to do, depending on what model, again, different models will give you different accuracies. That's why maybe someone used KNN. Maybe that accuracy is better than what we have so far. Basically, yeah.
Oh.
And Kaggle presents a very good place to keep learning. There are so many projects you can work on there to keep improving your skills, check what other people are doing. There's so much you can do on Kaggle. Alice is here. You can ask her questions. Alice.
She's not here. She does not look like she's on the list. Oh. I've shared the notebooks. I think are good enough to follow through on the WhatsApp group.
Thank you.
Any more questions before we call it a day? Okay, so please complete the project for your own understanding and improving of your skills. Sawa sawa?
So
Oh, I have a comment.
Yes.
Yes. So thank you guys for your participation so far. Those who are interested in joining the intermediate, they can sidebar me. We've been having a few classes in application level. The intermediate level, it's more of application. We've been doing topics in demand forecasting, credit scoring, model churning, and all those. So those who are interested in going on to the next level, I'll share with you the details. Like Tanvir, I've seen your message.
Oh, cool. Thank you.
Yes. That is it for the day.
All right. Happy Easter, everyone.
You too.
You too, guys.
Happy Easter. Take care.
Stay safe.
Bye.
Thank you. Bye
Okay.
bye.
Bye bye.